That will not change. So here is the question 23, non-abundant sums. So a perfect number is a number for which the sum of the proper divisors is exactly equal to the number. For example, the sum of the proper divisors of 28 would be 1 plus 2 plus 4 plus 7 plus 14, which is equal to 28, which means that 28 is a perfect number. A number n is called deficient if the sum of its proper divisors is less than n, and is called abundant if this sum exceeds n. So as 12 is the smallest abundant number for its proper divisors are 1 plus 2 plus 3 plus 4 plus 6, which is equal to 16, which is more than 12, is the smallest number that can be is the smallest abundant number. And the smallest abundant number that can be written as the sum of the two abundant numbers is 24. So two 12s together manage to get 24. By mathematical analysis, it can be shown that all integers greater than 28,123 can be written as the sum of two abundant numbers. However, this upper limit cannot be reduced any further by analysis, even though it's known that the greatest number that cannot be expressed as the sum of two abundant numbers is less than this limit. So we have to find the sum of all positive integers which cannot be written as the sum of two abundant numbers. So we know that the numbers that we should cover are all less than 28,123. And then we know what are the abundant numbers are. So we know that so if we imagine that A and B number A and B are two abundant numbers, and for all numbers that are greater than 28,123, there are at least two A and B which are abundant, and A plus B is equal. So what we have to do is to find the numbers and that are 28,123, and A and B are. First, we need to write a function to check if a number is abundant or not. So we define this function as if A for if abundant, and then it receives a number. And what it checks for is to see it adds the proper divisors of that number to see if the sum of the proper divisors exceeds the number itself or not. So this function is checking the value on the numbers that are abundant. So if I define an array, a Boolean array, and so if a number I put the value as true, else I put it false. So, and then later, when I'm looking to see if a number is abandoned or not, I just need to check the value. If it's true, then it's abandoned. If it's false, it's not. So, how to see if a number is abandoned or not? So, all I have to do is to see. I will go through the numbers that are proper of that number. And then, so I start from 1 because 0 is not counted here, and until itself because number is not included, so we don't put equal here. And then I check, so if number divides I, so I will add the sum, right? So here is should be initially 0. So here, if s is greater than number, it means the number is abandoned. Then I put the value in the number, right? So numbers of number is true, else is false. So I write a function to set the values inside there. And so this is the function that checks if a number is abandoned or not. So initially s, which is the sum of its proper divisors, is 0, and then I go through all the divisors of that number and add them together. If s exceeds the number itself, so it means that the number is abandoned, then I set the value as true. If not, I set it as false. So this function actually doesn't return anything. It just changes the value in the array itself. And then there's another function which creates the abandoned numbers. So it goes through the number between 1 to 28,124, which is the number that's mentioned in the question. And it will check for all the values inside there. And then, so these two functions together fill the array A. So what I do here, I set a boolean named flag. So if a number can be added by two numbers that are abandoned, then that number is not the one that we are looking for. All right. So there is an s here, which is the sum of the non-abandoned, those numbers that cannot be written as sum of two abandoned numbers. Cannot. Right. So I go through all the numbers between 1 until 28,124. Every time I set the flag as false, and then I start from 1 until the number, right? I check all the values inside the A array. A array is the array that says if a number is abandoned or not. So if the number is abandoned, then I will check the I minus that number. So if I minus that number is also is an abandoned number, it means that we can write the number as sum of I and j. Right? I'm sorry, as the sum of j and I minus j. So I set the flag as true. If the flag is true, then the number is not the one that we are looking for. But if it's not, so if there are no numbers that are abandoned, and those two numbers cannot be the number that we are looking for, so we set the sum as the sum of those values. And then at the end, we just write down the numbers, the sum of those numbers that cannot be written as the sum of the two abandoned integers. So if you run it, the value would be this. Yeah. which is exactly equal to the number of the answer.